In this lesson, we are going to learn how to write the names and formulas of ionic compounds, and specifically for this lecture, we're going to focus on binary compounds. So that prefix bi means two. So all of these compounds will have only two elements, like sodium chloride. It's made up of sodium and chlorine, two elements. So we're going to start by writing formulas, and then we'll go back and learn how to name them. So the first thing that you need to know when we are writing formulas is that we write the cation first, followed by the anion. Just like we saw when we did Lewis structures and we wrote some formulas, the cation comes first, the anion comes second. We need to determine the charge of each ion. Next, we need to remember that ionic compounds are neutral. That's like the most important thing when we are writing formulas. Ionic compounds are neutral. That means the net charge is 0. We need to determine the ratio of cations to anions needed to make a neutral compound. Let's look at some examples. Number 1. Let's say we have potassium forming an ionic compound with chlorine. So let's determine their charges. Potassium is a group 1 metal. It's going to lose one valence electron and have a charge of positive 1. Chlorine is a group 7 halogen, nonmetal. It is going to gain one valence electron. Its charge would be negative 1. When we write our ionic compound, the cation comes first, the anion comes second. Ionic compounds are neutral. Determine the ratio of cations and anions needed to make a neutral compound. Well, potassium is +1 and chlorine is -1. Positive 1, negative 1, that equals 0. If you need to, write out your charges and add them together. Positive 1, -1, 0. Since I only need one potassium and one chlorine, remember we don't need to write those ones in. Number 2. Let's do sodium and oxygen. Sodium is also a group 1 metal. Its charge is going to be +1. Oxygen is in group 6. It needs to gain 2 valence electrons, so its charge is going to be -2. This one is not a 1-to-1 ratio. Oxygen has a charge of -2. So how many positive 1s do I need to cancel out that -2 charge? Well, I would need 2 sodiums and 1 oxygen. Again, you could do the math, draw out all of your ions, and check your charges. Sodium is +1, and I would have 2 of them. Oxygen is -2. 1 + 1 is 2, minus 2 is 0, so it's neutral. Number 3. Calcium and iodine. So we want to figure out our charges. Calcium is in group 2. It has 2 valence electrons. It would lose those 2 electrons and have a charge of +2. Iodine is in group 7. It has 7 valence electrons. It wants 8, so it gains 1. Cation comes first. Anion comes second. Again, this is not neutral as is. How many iodines would I need to cancel out this +2 charge? Well, iodine is -1, so if I have 2 of them, that's going to cancel out that charge. Two minus 1 gives me 1, minus 1 gives me 0. Let's do 2 more, and then we'll go to naming. Let's do aluminum and bromine. And then let's do barium and phosphorus. When aluminum ionizes, it will have a charge of +3. Bromine will be -1. Cation comes first. Anion comes second. Think about the ratio needed to make a neutral compound. If aluminum is +3, I need a -3 to cancel that out. Well, bromine is only -1. So I would need 3 of them. If I have 3 bromines, each with a charge of -1, does that get me to a neutral compound? 3 minus 1 is 2, 2 minus 1 is 1, 1 minus 1 is 0, so we're neutral. Last one, this one is the most difficult. Barium would have a charge of +2. Phosphorus has a charge of 3 minus. We need our compound to be neutral. So right now, if I have 1 barium and 1 phosphorus, I'm not neutral. 2 minus 3 gives me a -1. Let's add another barium. 2 plus 2 gives me 4, +4. Phosphorus is -3. We're still not neutral. Let's add another phosphorus. Now I have 2 phosphorus ions, which gives me a -6. Barium is only +4, so I could add another barium. 2 plus 2 plus 2 gives me +6. So now these charges are going to cancel out. If I have 3 bariums, each with a charge of +2, that gives me a +6. If I have 2 phosphorus ions or phosphide ions, 2 ions, each with a charge of -3, gives me -6. So this compound is now neutral. Next, let's go to naming. Just like with formulas, the cation comes first. Never change the name of the cation. Don't add any letters, don't delete any letters, don't add any endings, never change the name of the cation. But for the anion, we are going to change its name. Drop the ending. And add the suffix IDE. All right, the cation comes first. We never change the name of the cation. Na is sodium, so I write sodium. After the cation, we're going to write the anion. For the anion, we're going to drop the ending and add IDE. So sulfur becomes sulfide. So we drop the UR in sulfur. Sulfur becomes sulfide. Number 2, write the name of the cation, never change the name of the cation. Mg is magnesium. Cl is chlorine. We're going to drop the ending and add IDE. Chlorine becomes chloride. Unfortunately, I have to say drop the ending and not say drop the last 3 letters because it's not always the same. In sulfur, we drop 2. In chlorine, we drop the last 3. In oxygen, we're actually going to drop 4. The best way to know the number of letters to drop is just to practice. The more you become familiar with these names, the easier it's going to be. Number 3, cation comes first, never change the name of the cation. You are just going to copy down its name exactly as you find it on the periodic table. K is potassium. Oxygen, you're going to drop the last 4 letters. Oxygen becomes oxide. K2O is potassium oxide. Number 4, Li is lithium. N is nitrogen. Here's another example where we drop the last 4 letters. Nitrogen becomes nitride. Think about what's going to sound the best. We wouldn't want to keep the O there and it'd be nitroide. That doesn't sound right. Nitride. It flows much better. Last one. Rb is rubidium. Never change the name of the cation. The cation always comes first. P is phosphorus. Again, we don't want to say like phosphoide. That doesn't sound right. We're going to drop the last 4. Phosphorus becomes phosphide.